GraphQL, and when to use it. Hi, I'm Sharakanski, and there is my dog, Kindle. I'm a software developer at Salto, and I use GraphQL every day, both in the backend and in the frontend. But enough about me. Let's talk about you. If you were Mark Zuckerberg in 2003. So, you're developing Facebook, and specifically the most important part of Facebook, which is the feed, of course. Now, let's say you're using REST API. And recall that REST API is an architectural style for web APIs, where we usually use HTTP methods to either get, update, create, or delete various resources. So how would you design the REST API for the feed? We'll probably have a /posts endpoint that returns a list of posts, and each post has text and creation date and many other details. And this works just fine. And after some time, you decide that you want to increase engagement, and you have this great idea. Add comments, because you believe that if people will see comments on the feed, then they will want to comment even more. So you want to show the top 2 comments of each post right there on the feed. How would you design the API? You'll probably add a field comments to the /posts endpoint, and this field will have the top 2 comments. And this works great. And after some time, you decide to hire a product manager. And she looks at the site and has this really great and innovative idea. Remove comments, because the feed is too cluttered and it should be nice and clean. So, what would you do now? You can just not show comments, but if your backend still returns comments, then it's pretty wasteful. So you want to not return comments from the backend. But this is a breaking change in your API, and it also requires some work in the backend, so it's not that easy. Anyway, you decide to do this change. Maybe you are creating a new API version just for this, and when you're done, your product manager has another great idea, and it's really groundbreaking this time. Add comments, but only for the website, because the app should still be clean. What would you do now? And note that this is not an easy question, because there are many possible solutions, but they all have disadvantages. So let's go over some possible solutions. Solution number 1, the /posts endpoint won't return comments. And then in the website, you'll have to ask for the comments of each post separately. This is called underfetching, because the /posts endpoint doesn't return all of the data that you need. And having to send these many requests, one for each post, is both slow and inconvenient. So let's look at solution number 2. The /posts endpoint will return comments, but in the app you just won't use them. This is called overfetching, because you're fetching more data than you need. And it wastes time because the backend has to calculate the top comments of each post, and then you just don't use it. And it wastes bandwidth because you are sending these comments to the client, and the client doesn't need them. It can even waste your client money because some clients pay for the bandwidth. So, solution number 3. You can have a parameter view, and the detailed view will include comments, so you will use this view in the website, and the standard view won't return comments, and you will use it in the app. But the thing is, there are many possibilities. Maybe you want to show the top likers of each post, and maybe you don't. Maybe you care about the author, and maybe you don't. So you'll end up having many views, like simple and simpler and full. And each view will be coupled with your specific frontend in that specific point in time. So if, for example, your detailed view includes the top likers of the post and the standard view doesn't because you don't show that information in the app, and then you decide that you do want to show that information, that even though your backend already returns top likers in the detailed view, you'll still have to change the backend in order to return it in the standard view. So every frontend change will require a backend change. And in the end, you'll have many views and you won't even remember which views you have and which values each view returns. So this is both confusing and not scalable. And the thing is, you can count on your product manager to keep having these great ideas, like to show the top likers of each comment, or to support Smart TV, which is a completely different view, or to support external API consumers, meaning people that are using your API for things that you don't anticipate in advance. And that's why your backend has to support in a convenient way many use cases. Now, let me introduce you to GraphQL. GraphQL stands for Graph Query Language. And I'll first explain some main concepts in GraphQL, and then I'll explain how GraphQL solves all of the problems that we have just discussed. So, the first main concept in GraphQL is the schema. The schema is basically a description of your API, and every GraphQL API must have a schema. In our case, this is what the schema might look like. So first we have the top level type query. And here we have our top level queries, which is the posts query that returns a list of posts, and the single post query, which receives an ID and returns a post with this ID. Exclamation mark stands for not nullable. Now, the type post has ID, text, and a list of comments, and the type comment has ID and text. Having a schema has many benefits. For example, the schema serves as a type system, meaning that GraphQL can generate from the schema types in our own language automatically. So it can generate the post and the comment type and many other types in C# or Java or TypeScript or any language that you are using. And another benefit of having a schema is that it serves as a contract between the client and the server. So when you are about to develop a new feature, the backend and the frontend can first decide on the schema together, and then they can start developing the features simultaneously because they already know what the API is going to look like. The third benefit of having a schema is that it allows introspection, meaning that if I'm about to use a new GraphQL API that I don't know, then I can simply look at the schema, and that will provide me with all of the information I need about which queries I can ask for and which return values I'm going to get. In fact, how do you query a schema? Simple. You send a post request to /GraphQL. So there is only one endpoint and you can get everything you need from that endpoint. And then in the body of your request, you send the query that you want. In this case, we want posts, and for each post, we want the text and the comments of this post. And for each comment, we want the text of the comment. The result of the query looks exactly like it. So we first have a field data, and then we have posts, which is a list of posts. Each post has text and comments, and comments is a list of comments where each comment object has text. So the result and the query are very similar. Now, if you don't want to return comments anymore, then simply don't ask for them, and then the backend won't return them and won't calculate them. This depends on the backend implementation, but it's very easy to implement this way, so the backend will only calculate comments when you explicitly ask for them. So as you can see, GraphQL solves many problems. It helps you avoid breaking your API, because if you don't want comments, you simply don't ask for them, and there is no need to change the API. The schema remains the same. Also, GraphQL solves overfetching and underfetching, because you get exactly what you ask for. Now, you may be asking yourself, how does this work? How come GraphQL doesn't calculate comments unless we explicitly ask for them? How is it implemented? Is this magic? Well, no, it's resolvers. And let me show you the TypeScript implementation of our resolvers for the feed. So first we define this object that describes our resolvers, and we have the top level resolvers, which is a single post and posts, and then we have the comments resolver, which is in the type post because comments belong to a post. Now note that we don't have a resolver for text, for example, because in this implementation we will always calculate the text of the post when you ask for a post, but we will only calculate comments when you explicitly ask for them. That's why we have a resolver for comments. Now, what is a resolver? A resolver is just a function. And let's look at some implementations. So first, the posts resolver. It doesn't need any arguments, and it returns a list of posts simply by calling a function, all posts, and this function probably queries our database and maybe does some more logic, and then it returns a list of posts. And note that we are only asking for the ID and the text fields of each post, because at this point, we are not calculating comments just yet. That's why we have the comments resolver, and this resolver will only run when you ask for comments. The resolver accepts one argument, which is the post that these comments belong to. So every resolver can accept its parent as an argument. The parent of comments is post. And then we just return a list of comments by using the ID of the post. And then the single post resolver is also very easy to implement, so I won't show it here. So as you can see, implementing resolver is simple, and GraphQL is very powerful. So you may be asking yourself, is GraphQL perfect? Well, not exactly, but I won't go over its disadvantages in this short presentation. However, I will mention two challenges that I have experienced with GraphQL. First, the learning curve, because to learn GraphQL, I first had to study the specification of GraphQL, and then I had to learn the specific packages that we're using at Salto, which are TypeScript packages. So I had to learn the TypeScript implementation in the backend and also another package for the frontend. And GraphQL is pretty different from REST, so there was a lot to learn. Now, the second challenge is the maturity of GraphQL, because GraphQL was initially released about 5 years ago to the public, and its stable release was about 2 years ago. So it's not as mature as REST. However, the community is very active, and GraphQL is maturing by the day. In fact, who is using GraphQL? Many companies like PayPal, Twitter, Airbnb, GitHub, and of course, Facebook, who invented GraphQL. And they're using GraphQL for a good reason, because as you've seen, GraphQL solves real problems. It helps you avoid breaking your API, and it also solves overfetching and underfetching. So the next time you are designing an API, I hope you consider using GraphQL. Thank you.